and I'm going to go into present mode. So yesterday I introduced the concept of calorimetry. A video was made for that. And I just want to remind you what's involved with a simple calorimetry design. So since we can't take a thermometer and stick it in a burning object, our thermometers would not withstand that, we need to find a way to indirectly measure the amount of heat given off by either a chemical reaction or by a burning food. And we can do that in this very crude design called a calorimeter, in which we have some water in here. And you have to find a way to support the can. This is an aluminum can. You don't need to write this down. All you need to do today is think. And this is a thermometer. It's measuring at a certain temperature. And beneath the can is a pedestal, and the pedestals I have made are made out of cork in a weigh boat, and there's a paper clip coming out of it. It's all wrapped in aluminum foil. The paper clips have been bent to support a snack, and we put a snack on there. Now, in order to figure out how many calories this snack has, we will take the initial temperature of the water, and then we'll light the snack on fire until it goes out, and we'll wait until the temperature stops rising, and we'll take the temperature of how much that went up. Now, I hope that it makes sense that if the heat from here is being transferred to the water in this aluminum can, that the heat would go up. The temperature would go up. We're transferring the heat, the temperature is going up. Now, yesterday when I introduced calorimetry, I said that we make an assumption, and it's a bad assumption. The assumption is that all of the heat goes into that water, when in actuality, we lose a lot of heat. So let me just use this as a key. So this is lost heat. And we talked about where we can lose this heat. We can lose it to the surroundings, especially if you have a snack that's more flattened. That flame kind of goes out in that direction. So we can lose it to the air. We can lose it to the can. So that can absorb some of the heat. Some of the heat can go into the water and leave the can this way. Some of that heat might escape this way and out that way. Now, with the calorimeter design that I showed you, which is a traditional calorimetry setup for high schools across the United States and the world, there is a lot of heat loss. So my challenge for you is to build a calorimeter that will maximize heat transfer, which means we want as much of the heat from that burning snack to go into the water. So we're maximizing heat transfer to the water. And we are minimizing heat loss. And at the same time, making sure we have enough airflow in to, let me have this be some airflow. We need to make sure we have enough airflow in to support the burning of that snack. So we need proper airflow. 2 years ago, I introduced this project for the very first time. Prior to that, we just used a simple calorimeter. And then I thought to myself, what if we can make it better? What if we can trap more of that heat and transfer more of that heat and get a more reliable result? So I sent my students to that task. It was the first time I had ever done it before. And they came up with about 50 very unique designs. And I'm going to share a couple of them with you right now. So this was, I think they had a can of some sort inside. This is some pink insulation. Again, the goal is to somehow maximize that heat going to the calorimeter, to the water, and minimize heat loss. So they had the can with the water up here. It was sitting up pretty high. Some groups had similar designs, but they brought that can with the water down a little bit lower. They have some insulation there to trap the heat. It is still very open here on the bottom. So I don't think that this group took that into consideration, the amount of heat that could leave laterally. I think they're trying to trap a little bit of it here with this cutoff can. When they were burning this as well, you can see that there are holes in here, and the holes were put there for airflow. And this contraption is sitting up higher, so I think that it was raised, or it was lowered, so that that flame would have been sitting right in here. It looks like there's a hole right here that they tried to use to light the snack with. So now that I'm looking at it in more detail, it looks like this was this contraption was lowered. This was designed to channel the heat upwards, maybe reflect it instead of allowing it to leave laterally. So that's one design. This is another design. This group of gentlemen thought that the wood would act as a good insulator. They had lots of obstacles that they had to overcome with this, because they didn't realize that you have to take the snack in and out each time. Because before we do this, we have to get the mass of the snack. We have to take into account how much of the snack burned. And then we have to get the mass of that system afterwards. So in your design, you have to make sure that you can remove that assembly that's holding your snack and put it back in. They had that snack assembly down here. They had to take the can out each time. They were lighting through this little hole down here. They realized they did not have enough airflow, so they had to keep drilling holes until they had enough airflow. And eventually they had some success. I'm not even sure what this design is here, other than I don't think it's a very good one. I don't think this is much different than mine. They have the snack burning on top of some foil, which is on top of some sand in a container, but everything above it is the same as that traditional setup. They didn't get much different results. This was a coffee can. Now, I am going to have you guys be bringing supplies in from home. You are going to be building calorimeters, and I don't have the supplies, so you're going to have to supply materials from home. I will have foil and some other things, but they have the snack sitting in there. It's on a pedestal. It's metal on the inside. I think they thought that the metal would reflect heat and keep it in and move it upwards. There's a hole in the top of this cover that somehow supports the can with the water in. I don't have the top view of this. This group had a challenge that they didn't have enough oxygen, and they didn't want to cut holes in their calorimeter because they had pretty sparkly tape on it. Not that functional, but good looking, I guess. So had you guys been here within the last few weeks, we would have done this activity in which we used a container like this to make oxygen gas, to generate oxygen gas. So they got this idea like, oh, we need oxygen to make it burn. We don't have enough airflow. And they asked me, can we make oxygen and pump it in there? And I said, sure, that's a great idea. So they were using some skills that they had learned before. And they were able to provide enough oxygen to keep the flame going in there, and it ended up working well for them. I think the tape around here is to act maybe as some insulation. This group had a plexiglass box. The top of the box was white or pink insulation, and it's wrapped in foil. The sides are also wrapped in foil, the pink insulation. There's a platform in there for the burning snack. They have this can supported. This pane in front is a pane that slides up and down, so they control airflow that way. And they had a pretty unique design. This design involved a piece of PVC pipe. It was lined on the inside with aluminum foil. They had to do a lot of experimentation trying to light the snack, get enough airflow, but eventually they got it to work. The can is nestled inside that the top of that PVC pipe. This group has a little guard here. There's some sawdust shavings in there. They thought they would use that as insulation in this coffee can. They had a hole in the bottom for some airflow and also to light the snack. And this group had, it was a really poor design actually, because metal conducts heat really, really well. And they took 3 pieces of sheet metal and put them together like a triangle. So it'd be like a triangular column. They taped them together using a aluminum tape. And then they just kind of lowered that contraption on top, above the burning snack. And honestly, I think what happened really is that metal heated up and it just really dissipated the heat outwards more than it channeled it to the can. So this design was not that functional. And that's the end of the examples I'm going to show you. I had so many more. And but I don't want to show you all of them, because I want you guys to think outside the box and come up with a design together. And we need to do this in a way that promotes social distancing. So I am looking for groups of 2 or 3. I'm going to stop the recording temporarily. I'm going to make some breakout rooms. We're going to make these groups together. And here, stop the recording.